Welcome to EEMS 260. This video provides a brief overview of the graphical features to set up and configure the EFDC Plus original sediment transport model. Let's get started. To begin using the original sediment module, you can start by opening a model in EFDC Explorer, and then activating the original cohesive sediments and original non-cohesive sediments module. To begin setting up the module, right-click on Sediment and click on Settings to open the sediment settings. Under the Major Settings frame, the user may specify the number of sediment bed layers and the number of cohesive and non-cohesive sediment classes. In the General tab, the user can tell EFDC whether or not to simulate cohesives and/or non-cohesives and the approach to compute bed shear stresses for sediment transport. Unchecking all the Simulate Cohesive and/or Simulate Non-Cohesive checkboxes does not delete previously defined sediment transport parameters. It just turns off the EFDC computations for that parameter. The bed shear stress calculation options allow the user to choose from a number of different calculation options for bed shear stress computations. If non-cohesive and cohesive calculations are being performed, it is generally preferred to use the separate bed shear stress into cohesive and non-cohesive options. The sediment time step field specifies the frequency of sediment transport process computations during the simulation. In the Cohesives tab, the user should specify the cohesive settling flag. If the Apply Vertical Diffusion option is checked, then vertical diffusion will be applied to the cohesives. The user sets the maximum and minimum cohesive fluid concentrations. We will enter some values for the fields in the Erosion and Deposition Parameters frame. In the Non-Cohesive Suspended tab, there are a number of options for computing equilibrium concentrations. This includes the option of equilibrium concentrations calculated from sed flume data, with or without critical shear stress. The user needs to select one of these options. Enter values for fields in the Erosion and Deposition Parameter frame for each non-cohesive sediment class. In the Non-Cohesive Bed Load tab, the use of gamma parameters varies slightly between the different EFDC codes. The user should know how the gammas are used by reviewing the code prior to finalizing the desired inputs. Pressing the Initialize Constants button will bring up a dialog box asking the user to select the bed load approach to use. EFDC Explorer sets the bed load transport constants to standard literature values for the computational approach selected. The Bed Load Phi Options frame allows the user to choose from the following options: Constant or Manual, Van Ryn, England-Hansen, and Wu, Wang, and Jia. The Cell Phase Transport Rate option allows calculations based on the following options: downwind projection with corner correction, and by averaging vector components. In this tab, the user may specify various bed consolidation and bed morphology settings. The Bed Morphology Options frame allows the user to choose between the morphologic feedback to hydrodynamics or not by using the checkbox. Bed and Deposition Settings frame allows the user to set bed change parameters. The Bed Consolidation and Mechanics Options frame provides input to the main sediment bed consolidation options. The bed mechanics options must be 0, none, 1, simple, or 2, finite strain. The consolidation rate is in seconds. The Bed Processes allows the user to select from No Armoring, Non-Cohesive Armoring for Garcia-Parker, and Armoring with Active Parent Layering. For the case of armoring with active parent layering, the user needs to specify an active layer thickness. The user may also specify the non-cohesive resuspension options, with a choice of modifications based on coefficients input by the user. This option modifies the critical shear stress for resuspension based on the fraction of cohesives. In the hard bottom option frame, the user can define which bed processes are active or not for a region or all cells by checking the Use Cell-by-Cell hard bottom assignment using bedmap.imp checkbox. Once checked, the Assign button will be enabled and will allow configuration of the cells. The user selects one of 4 options in the Sediment Initial Condition Options frame. These options are Constant Water Column and Bed, Spatially Varying Water Column, Spatially Varying Bed Concentrations, and Spatially Varying Bed and Water Column. If the user selects Bed Mass Specification options to specify the mass fraction, then the bedlay.imp file will be required as an additional initial condition file. Click on the Assign Bed IC button to open the Initialization of Sediment Beds frame. The Initialization of Sediment Beds frame provides a number of options to build the sediment bed. Boundary conditions for sediment must be configured using either a constant value or time series. Time series can be added from the sediment module settings. The time series for sediment concentration can be configured using the Boundary Data Series editor for sediments. Each series can include concentrations for each class defined in the sediment module. Concentrations can also be set for each layer. To complete the setup of the sediment module, time series data must be linked to the model boundary conditions. The boundary group concentration frame can be used to complete the linkage between a flow boundary and a sediment concentration time series. To complete the setup of the sediment module, time series data must be linked to the model boundary condition. Now that the boundary conditions have been linked to the time series of sediment concentrations, we can save and run the model. Thank you for watching. You can find the link to the next video below.